Hello. So this is for the Louisville, Kentucky. We're looking at June 21st, 2019 scenario at 2040 Zulu. And so what we're going to focus on is kind of the middle of this QLCS segment, this Boeing segment. It's a very cold pull driven storm as you see the most of the precipitation is lagging behind. You have some stronger convection or some convection that is sparking out ahead of the cold pool. So maybe the cold pool is starting to outrun this system a little bit. But we're going to hone in here on the center where we see this rear inflow notch as the center of it goes. We're going to go to base velocity. And you can see at base velocity as the inbound the inbound velocities start to increase with the storm segment and actually start to overrun the convergence zone. So we can expect some very strong winds. And of course, there's some down power line report, tree limbs down within that segment right there. So if we look closely, we do have some close to 60 dBz 60 reflectivity, and so we can look at dual pole to see if we see any hail in there. So let's go into our panels, and we'll do 4 panels. You always want to make sure that you have some reflectivity when you're looking at these. We'll place a marker here. And note that in the KDP, especially with coinciding with that 60 dBz, you have some higher KDP, so maybe a little bit of hail mixed in with that, but mostly just heavy rain, as KDP would indicate, and also you don't see a big drop in the reflectivity values, and then we can put a correlation coefficient on here and see that this is mainly what we're looking at. Most of the not a big change in the correlation coefficient, and then not a lower dB value in that. So let's go over to the panels, and actually let's do some volumetric scans with this. So first we can do a cross section and just look at the storm structure. So most of the storm, now we have to also consider that this is, exit that. We have to also consider that this is pretty far away from the radar. We're looking at about 7,000 feet in the air. So with that being said, that's where our lowest scan is going to come from. But most of the reflectivities are in the lower levels with this system. And then we can kind of swing back and forth and see that there isn't really a great vertical structure. It's pretty linear in nature, so not a whole lot of organization other than just the linear nature of it. And then we can do a volumetric scan from the point that we're interested in, where this rear inflow notch is. And we can see how this evolves over time. And so with the volumetric scan, I have the lift volume, so I can show you where I'm kind of looking at mostly the higher reflectivities, and then kind of phasing out some of the lower reflectivities, but we can still kind of see the structure of that, and then we can see how that changes over time. And as you can see, the storm just kind of bubbles up and falls down as that cold pool drives that convergence out ahead of it. So you wouldn't see much structure. You don't see many supercellular activity going on. And then we can flip it back over to velocity to see if we can find any bookend vortices with that. I have storm relative velocity with 270 at 27 knots, indicating the storm motion. So, and as we loop through, there isn't much in the way of any vorticity with that, or bookend vortices, as in some cyclonic or even anticyclonic rotation with this system, but that strong convergence zone out ahead of the stronger velocities with that convergence line is indicating some damaging winds in there. Maybe a collapsed cell within that line is creating that, but getting some storm reports. It seems it's kind of going in between Fort Branch and this in Princeton, so headed towards Somerville, or there might not be many reports in there at that time. We can follow this to see if we find any reports of strong winds in this area, and see not much in the way of strong winds for this area. So this is pretty much it for this segment, and once again, quasi-linear stationary boundary that's kind of set up. There was a little more convergence in the southern half of this, as it's more of a southeasterly flow. This more westerly flow it doesn't have quite the convergence and maybe not quite the instability as the southern part of the system does. So we might see some more severe weather down in these parts, but not a whole lot of hail, as the dual pole would indicate, and then no rotation, just very strong winds with that rear inflow notch, and then very cold pool driven. Looks like the cold pool is coming out ahead of the system. So that's it. That's the summary for this. We can go over to some echo tops. We can overlay that with some Ville and some stronger Ville and higher echo tops with that. But it's ranging from 30 to 40 to 50, maybe even 50. So as you get south, you get some of the stronger hail indicators. So we get into the 70, and of course they had a 1-inch hail report in Owensboro with this. And that's where we expect with the higher echo tops and the stronger values. But other than that, there's not much else going on with this. A pretty classic QLCS, maybe a bow echo type, especially down towards the south where you have so many strong wind reports. But we'd like to see something from the HPX radar for that scenario. If you wanted to check out how the southern end of the storm did, or even the Paducah radar would have a better handle on how that storm is evolving down there. But for KLVX, it looks like it's just kind of common QLCS, some hail, some strong winds in that. And so that's all I have for now. And that sums up the briefing. Thanks.